Okay, so what we're going to do in this video is we're going to talk about the last of the existence theorems that we need to know. So earlier in the year, we talked about the intermediate value theorem, which you should be able to look back at your notes and study, and the extreme value theorem, which we learned earlier in this year and we revisited in the last section. So the third existence theorem that we're going to need to be aware of is called the mean value theorem. And mean value theorem, we'll abbreviate that MV2. So what I'm going to do is I'm going to start by drawing a function that's closed, so I've got endpoints, and continuous and differentiable over the interval at which I'm looking. Now, the mean value theorem is important because it connects the two concepts of rate of change that we've talked about this year. The AROC, which is the average rate of change, that's the slope between the endpoints, and the IROC, the instantaneous rate of change, which is the slope of a tangent line. So if I were to draw pictures of these things, if I draw a line that connects the endpoints, that's called a secant line, and the slope of the secant line is the average rate of change for the interval. Now, I want you to imagine that you're riding on this graph like you're riding on a roller coaster track, and that the tilt of the car you're sitting in is the slope of the tangent line. So as I move along this graph, there's going to be a couple of places on this graph, right here-ish, and right here-ish, where the IROC, which is the slope of those tangent lines, is parallel, in other words, the same as the slope of the AROC. So what we're interested in talking about with the mean value theorem is places where the IROC equals the AROC. So here's what the mean value theorem actually says. I'm going to say it in words and then I'm going to write it in math. So in words, it basically says if f of x is differentiable over an interval, an interval, not interval, then there is at least one place in the interval at which the IROC equals the AROC for the interval. So the mean value theorem basically says, in this picture that I drew, there are two. I could have drawn a situation in which there are 3 or 4 or 5. But mean value theorem says, as long as that function is continuous and differentiable, I don't really have to say both because differentiable implies continuous, that there will be at least one. Hence the existence theorem thing. Now, if f of x is continuous for the interval from x equals a to b inclusive, and differentiable for x in the interval from a to b not inclusive. Now, the distinguishing point between those two is we want the graph to be connected, we want the endpoints to be included, but at the very end, the derivative itself doesn't have to exist. It's almost always going to in the situations that we're working with, but just in case it doesn't, we don't have to worry about it. Then, there exists, that's not how you spell exists, some number c in that interval such that. So there exists some c, that's the same thing as saying there's at least one place in the interval at which the IROC, which we find by taking the derivative and plugging in c, so the IROC at that point is equal to the AROC, which is the slope between the endpoints. So this is the mean value theorem. So I'm going to make one more video that shows an example of working through a problem with the mean value theorem, and then we will talk more about it in class.